Okay, so up to this point, we have defined a simple function, and we saw that two different functions can do the same thing. But what are some of the best practices about naming functions and their arguments? Well, first and foremost, function names cannot be more than one word. If you want to have multiple words in your function, then you have to put an underscore. You can't, for example, say define my function and then take args. That won't fly. You have to have something along the lines of an underscore. You also can't have a dash. It's underscore or nothing. You can't have a dot. So there are several things you can't do in a function name, and trial and error will definitely just bring those to the forefront. You can't have a function name that begins with a digit or with a funky character. None of those is going to fly. And the word function itself is already reserved by Python for functions, which is why myfunc is a good choice. Or, you can get pretty creative with your function names. Finally, though you can use camel casing, you can say my awesome function like that. Typically, camel casing is reserved for the granddaddy of functions, which is known as the Python class, which is a collection of multiple functions all tied into one. So best practice, again, is to always use lowercase. Now let's try breaking functions, okay? So far we've written a function. In the notes it says it was called addition. I named it myfunc. Now let's try to break our function. Myfunc took in two numbers and it added them, right? And that works just fine. But what if instead of 2 and 3, I give it 2 and 3? Well, that works, but it now gives me back 23 because it's treating them as strings, right? This, oops. Remember that we can add strings. If that would stop, please, thank you. We can add strings. This is a string, and it will add those two things together. But what happens if I try to add this as a string and a real number like 5? I get an error message. And their error message is unsupported operand type for integer and string. You're not allowed to add a number and a string together. Likewise, if I were to do that with 5 and a Boolean, such as the word false, that's actually going to work because false is a 0 and true is a 1. But if I put that into strings, now once again I'll get an error message. So how do we handle that? Functions have a built-in best practice called error handling, also known as exception handling, which is where you try and think ahead of time about everything that could possibly go wrong when you put your precious function in the hands of an untrained user, and then you account for that ahead of time, sort of like reverse engineering problems. So break the function. There are several examples of breaking the function in the final code, most of which I have. None will also break it, by the way. So none is a similar Boolean. Right, also breaks it. So lots of things could go wrong, and even a list, if you have a list of numbers, right? Let's delete that. 2 and 3, comma, 5 and 4. Well, you can actually add lists, true enough, but it's not doing with it what I wanted it to do. Even though it's joining them, it's not performing a mathematical operation on them. So I'm going to recreate my function to avoid some of those issues. I'm going to call it myfunc2, which can take in two arguments, which are going to be v and k. And this time, I'm going to start out with an if statement for the exception handling. If type of v is equal to double equal to integer, and type of k is equal to an integer, then and only then return v plus k. Else, return, please provide a numeric input. Or better yet, if you want to use an f string because you're getting fancy, return f, your arguments, v and k, need to be numbers, right? Something like that. Oh, I forgot the DEF at the very beginning. There we go. And now when we try myfunc2, It still works with 2 and 3, but if I put one of them as a string, oh, sure enough, there I got a little too fancy. Sorry, you can't do that with f strings. Oh, is that what it is? Ah, thank you. Ah, there we go, sure. Okay, perfect. My error handling actually worked in that example. Checking for the type of inputs is the most frequent error handling. Another one that you might want to deal with is when somebody provides you 3 inputs, that'll also generate an error. In which case you might want to say something along the lines of, if the length of list vk is equal to 2, then do all these things, right? But that's a little more error handling than I want to deal with on the first time around. So we've added some exception handling to our argument. Now let's define another function called addition list. Define addition list as being a function that can receive any list. And it will start out with a running sum equal to 0. And then for every item in my list, it's going to do something with those. What we'd like it to do is build running sum plus equal to item, and then return running sum. And now if I take addition list and I feed it some numbers, such as 1, 2, 3, 4, it'll add those up and give me back 10. So that's a nice way to, build a function around a list of numbers. But of course, we might have an error handling if one of those is a string, because once again, we can't add those. So let's add in an if-then statement to handle all of that. For item in my list, if type item is equal to integer, then go ahead and add those together and return the running sum. We actually want this a little further out.
Would it run if you didn't have that correctly?
It may or may not run, but it will not produce the results that you want. The level of the indentation is actually quite important. If I put it all the way out here, it definitely won't run. If I put it here, it will return the final result. If I put it here, it will return multiple running sums at every step. Yep. So what I need to add to this is an else statement. Else, so if it's not integer, you could simply pass, like skip that, or continue, and that actually works. It's simply ignoring 4. And if I put more digits after 4, it will actually add all of those up. So that's a nice way to skip anything that doesn't fit the required criteria. The other thing that you can do is to print, please give numbers, and then to break. And that will stop the running sum at that point. Right, so it gives back my error message, and then it also adds the numbers up to the error, but nothing beyond the error. Okay, here's a challenge. Can you write a function that returns the length of every word in a list? This time I will time it, and then I'll give the answer in 2 minutes so that I don't get off track. You guys are on track.
So say the length of every word.
Yes, write a function that would return the length of every word in a list. and post it in Slack. So I'm keeping an eye here on Slack to see those.
So how do you make input parameters as a list?
You want to use not square brackets.
Oh, yeah, and then column whatever.
And then don't actually give it a list, but rather a variable called my list for these colors.
And we'll know that's a list.
No, it won't.
It won't.
But then handle it like a list inside the function.
Okay.
Yeah.
So
Similar
it's-
to this example that I have up here, I just called it my list, but then inside the function I have a for loop for item in my list, do all this stuff.
Okay.
So really your function will probably have this line and this line, but it's the middle part that probably will differ on yours.
I'm going from a SQL world where you define what type of input parameters, the data type of each.
Ahead of time, yes.
So we don't do that.
Python proceeds along the lines of a sort of an innocent until proven guilty. Like you don't actually have to define it until it breaks, and then you do.
Okay.
Whereas SQL's the other way, it's like guilty until proven innocent. Okay, great. And these all look great. Just as a quick kind of aside, Hacker Noon So Eric brought up something that is part of kind of the philosophy of Python, which is known as duck typing. Most other languages require you to define data types before they get used so that there won't be any mistakes downstream. Python takes an approach of sort of let 1,000 flowers bloom until an error happens. And this is known as duck typing. And this is a nice little article here along the lines of, if it looks like a duck, it swims like a duck, and quacks like a duck, then it is probably a duck. So when you define a variable and you assume it's going to be a list, you just treat it like a list, and Python goes along with that until at some point it generates an error message. And this provides greater flexibility, as this article mentions, greater flexibility than other languages, because in other languages you must declare an explicit variable type or interface ahead of time before you use it. But as he points out here, there are weaknesses to this approach in terms of especially unnamed dependencies and downstream effects that you may not anticipate, and times when it ought to generate an error message and doesn't. So those are the kind of the trade-offs. But this is one of the things that makes Python distinct from older languages like SQL, or certainly the statistical programming packages that I was familiar with back in the day. So thanks for bringing that up.
Sure. Can you slide that up?
Oh yeah, sure, totally. Put it here in general. Let's put it in general. It's good. Duck typing. Okay, so that's enough for intro to functions. Now let's take a look at basic functions. Notebook number 2. 3 and 4 are sort of just additional exercises. So if I only touch on those, I'm not going to shed any tears. This is going to be a series of examples of building functions from simpler to more complicated. Go ahead and type along with me in the lessons notebook. So the first one is to build a function that computes the volume of a sphere given its radius. Here's the formula, 4/3 pi times radius cubed. So let's define a function, and we can call it my volume, and it will receive an input called rad, colon, and it should return 4/3 times pi, 3.14. You could also use NPPi. I think this is also something that exists. But you'd have to import NumPy first. So I'm just going to go with 3.14. And then you can multiply that times whatever the input rad was cubed. And then we can check that my volume, if I feed it a circle with radius 2, I'll get back a volume of 33.49. And like we did before, if I feed it several, list of radii would be equal to 1, 2, 3. I can print for x in list of radii, print my volume x. And it allows me to reuse my code in a very efficient and accurate way.
So since there's no, you don't have to define the input parameters or arguments ahead of time, is there a standard for naming arguments?
So I've seen a great deal of creativity in this, and on my team I've got one of the coders who just names it after like cartoon characters and superheroes, just to, shake it up a little bit. I think the number one rule is that it needs to be interpretable. Oftentimes people just do X and Y or IJK. I see that a lot. But the problem with doing that is that you end up, when you have a lot of functions, they all look very similar, and it's hard to distinguish them or keep them apart. But no, other than that, I don't know of any best practice. What is a best practice, however, is, especially with longer ones, to put a comment in here saying the purpose of my function is to calculate the, what am I doing here? Volume, right? And in addition, if we wanted to add some error handlings, we could have added something along the lines of if type rad is equal to integer, right? Else pass or something like that. So that would mean that if I fed it a string, too, then it doesn't give an error message, it just moves on.
Sorry,
Yeah, go for it, please.
If you had like a variable that was defined as rad somewhere else, would that cause a problem?
Oh, that's a great question. I'm so glad you brought that up. That refers to something known as local versus global scope. Local means inside the function, and global means across your entire script. So out here, I define rad is equal to 3. And every time I call back rad, it's always going to give me 3. But I've also used a variable named rad inside my function. Does it understand that? Will it always give back 3? No, it won't. And the reason why is because everything inside of a function is treated as sort of a microcosm, as sort of its own mini universe, independent of anything that was defined outside the function, and vice versa. If I put something inside the function and I say x is equal to 5 and I run this, and now outside the function I try and print x, x is coming back as 3 because it was actually used here, even though I've overwritten it as 5 there. I'm actually not sure where I defined x as 3, but it wasn't here. That's curious. I must have done that earlier when I was tinkering around with this.
Oh, okay, then that.
Yeah, it must be. Yeah, that's what it is. That's exactly, there it is. It's right there. It's the last element of the for loop. So yes, that's a great question, and the answer is no. You can. It's completely independent of each other. Okay. Next exercise is write a function that checks whether a number is in a given range inclusive of high or low. So I'm going to def define my function. I'm going to name it rancheck, and it will receive a number, a low end, and a high end. So if number is in range, low through high, or high plus 1, of course, print f string you picked, and it is between. So what did you pick? You picked num, and it is between low and high, end quote. Else, print no. Let's keep it simple. What did I do wrong here? Expected an indented block. I gave you an indented block. Is it the level of the indentation? I'm actually not sure why this is bombing on me. Right, if number's in the range, low, high. Is it my print statement? I feel like this should be more obvious than it is.
Is it because you have to have 3 parameters in the if statement?
I do. I have all 3 parameters, num, low, and high. Not only do I have all of it, and I don't see what the error is, and I'm sure it's something really simple, but I'm also following the solution code that I checked prior to class. I'm sorry, guys. I hate to gum this up, but maybe if one of you spots it first, that'll be also a good, facts check.
I have it typed exactly as you do, and I'm not getting any output.
You're not getting any output.
You have to run the next. You have to give it
Huh.
input.
That's interesting. It didn't like that. I didn't expect that. It's the comment at the very beginning. That must be a Jupyter Notebook thing. I haven't seen that before. Well, okay. Else, print. Going back to Jason's comment, Jason, if you add an else statement, please try again. Something like that. Now does it give you any output?
Nope.
Ran, check, 4, 1, 5. And check is not defined because I misspelled it. Okay, well there must be a difference between
Got it.
something in there. You got it?
We're good.
Yeah? Okay, great.
Is there a difference between using print and return? Is that practice?
Yeah, that's a great question. So here I'm using print, elsewhere I used return. Print will do what it says. It will print a result, but it won't store it to memory. Return stores it to memory, but may or may not print it, especially if you work through a loop. For example, going back up here, I return the results, but I don't print them, which is why down here I had to actually print those results each time. If I were to change this to a print, then I wouldn't actually have to use print here. It would just print all of them. But it was going to error out at one of these because I added a string. Or whatever, or something else happened in there that I don't want to troubleshoot. But to get to your question, the best practice of doing that is that when you define a return statement, such as myfunc num equal to num plus 1, and I'm going to put a return in there. I'm going to put a def. And then I can set x equal to myfunc 4. Now when I call x, I've stored those results as a new variable. If I had changed this to print, then I would not be able to do that because return stores it, but print does not. Is that a good explanation?
Yeah. So
Okay.
if you want to use the output.
Exactly. If you want to use the output of your function, definitely have return.
Can you return and print, or is that
I
great?
do not think you can. Like this, return, print, no. Not only that, but I think if I set it to print and then I try and set it equal to a function, I think this will also generate an error message. No, it doesn't. But it doesn't store it, right? My func doesn't remember it. So now when I call x, it doesn't remember that it's 5, but at least it didn't break it. Yeah, definitely. Moving forward. Write a Python function that accepts a string and it calculates the number of uppercase letters and lowercase letters. So here's an example of what it should do. It receives this sentence, and it calculates that there are 4 uppercase letters and 33 lowercase letters, and it can do this for any string. So keep in mind that if we call s, and then we bring back s0, it'll give that back to us. And if we set s0 equal to lower, it'll turn that into a lowercase item. So based on that function, the dot lower and the dot upper, and also the is lower and the is upper, that's the one we want to use. This is a Boolean that will test whether any given letter is upper or lowercase. So let's put in a comment on that. Test whether a letter is uppercase. This is a built-in Python function. So armed with that knowledge, let's go ahead and build this one out. I'm going to define my function as upload, and it's going to receive any sentence called S. Let's call it sentence. Okay. Now we build a dictionary called D, and set D equal to two values, upper is 0 and lower is also 0. So to start off, we'll just have this dictionary, and we can print D as a result. Now when we take upload, this is the best way to build out a function, by the way. Start really small, make sure your code runs, and then build outwards from there. And I think I'm actually going to do it here. Upload to S. So we defined S earlier as hello, Mr. Rogers. I'm going to keep using that. Now my function simply prints an empty dictionary of 0 and 0. And it'll do that no matter what S is set to. Now, for C in S, print C. Let's try that and see what it gives us. It takes every letter in my sentence and it prints it out. Our code runs. It's not doing what I want, but we're building it out little by little. Now for S in C, for every letter C in sentence S, if C is upper, print C. Okay, so far so good. Now we're getting H, M, R, and T, which is what we would have expected. But instead of printing C, let's add it to our dictionary. Let's say D key upper plus equal to 1. And now at the end of this, print D. Now we've got a dictionary where upper is equal to 4 and lower is equal to 0. See where this is heading? It's counting letters and it's adding them to a dictionary. And likewise, else if C is lower, can you guess what I'm going to put? D lower plus equal to 1. And I missed a step in there. Oh, it's LF, not LF. And now I've got a dictionary that, again, is counting all the uppercase letters and all the lowercase letters, and it's keeping a running sum inside the dictionary. And if neither of...
Where's it getting the letters from?
Yeah, let's go ahead and bring those things a little bit closer. So this is the sentence S. It's a sentence about Mr. Rogers, right? So it's from there. H, M, R, T is upper, and everything else is lower. But what about the question mark? That's neither of those two things, right? So right now, let's just go ahead and add an else pass. Or better yet, even continue. Just as sort of an error check. But now finally, instead of printing D, we could print D upper, comma D lower, and maybe do some other string manipulation around those two letters.
So it automatically knows, oh, I see what is upper, okay.
Now suppose we define a new sentence. New is going to be equal to, here I'm just doing random string of stuff, and I asked it to do up, low, new. Oh, I know why, because I put S instead of sentence. There we go. Now it's getting 9 and 27. Questions about that exercise?
Is there a, like, instead of is lower, is upper, is there like an is symbol or non-word character? Do you count symbols or spaces? Or I guess you can find a space.
So you wanted to count, for example, this.
That or the commas? Or
Probably in that case, I would do something along the lines of if C equal to, whoops, if C equal to space. And that would do the same thing. Or
So-
whatever character you would like, a question mark. Yes.
So is lower and is upper is a built-in,
Yep, it's just a built-in Python string function. Okay, the next one is write a function to multiply all the numbers in any list. This one's a little bit simpler. Did I skip one? Write a Python function that takes a list and returns a new list. Okay, I must have skipped one of these when I filled out the, I'm going to go ahead and put it in here. Function that takes any list and returns a new list with unique elements from first list. Okay, so this probably is going to be using, or could use, a set function. So here we're going to define a new function called make me unique, and it's going to receive any list. Oops. And again, let's build it out little by little. Return any list. Okay, so there's my function. And now I'm going to build out something called new list. And we'll set this equal to something with a lot of repeats in it. A bunch of 4s, a bunch of 6s, some 7s, an 8, a 9, a 3, and a couple more 3s. Okay, so there's new list. And now when I take my function, make me unique, and I feed it new list, it's just going to print that back out. But of course, what we want to do is find all the unique elements. So we could call something called results is equal to set any list, and then return results. And that automatically teased out all of the unique elements, but it still has these funky brackets on either side. So maybe we could do turn it into a list, or if we wanted to get rid of them altogether, we could say, and see if I can do this by memory here, x for x in, and that of course has to be, well anyway, I'm not going to fuss with that right now. This is more than good enough for the purposes of this one. Brings back the unique elements. Do you remember sets from 2 nights ago? Or maybe that was just on Thursday? Yeah. Like a list, but unique. All right, write a Python function to multiply all the numbers in any list. So in this case, 1, 2, 3, -4, the result ought to be -24. I'm going to define my func. It's going to take numbers list and start out with a total as equal to 1. And then for x in numbers list, so notice that functions use for loops an awful lot. They love for loops, they love if-then statements. Return total times equal, that is to say, times itself equal to x. And then once all of that is done, go ahead and return total. Let's go ahead and take the sample list provided and then my func provided gives us back a -24. Perfect, and if we add another digit in there, the output will change. This math function is coming in as familiar. Plus equal, times equal, minus equal. Takes anything, and then in this case, it would multiply it by that element. Write a function, write a Python function. This is the last one. second to last one, the pangram one, is actually pretty tough. That checks whether any past string is a palindrome. Right? Race car, nurses run, God and 8-bit a Tibetan dog. Right? All of these are common palindromes. We want to check for any one of these if it's a palindrome. So we're going to define our function as pal checker, and it's going to receive an argument. First, replace all spaces with no space. And we'll call this S is equal to, sorry, it's arg dot replace. So dot replace is a built-in string method. Replace any space with no space. And let's just return that and see what our function does. So let's give these numbers, I'll call this A. I'll call this one B. I'll call this one C, D, and E. And now I can bring back pal checker and feed it A. Oh, I didn't actually run these cells. And it gives back the palindrome, but without any spaces. That's great. It's doing what I wanted it to do. Or E, madam, I'm Adam. Or C. So far that's working nicely. It's replacing all spaces with no space. But that's not the full functionality that I wanted. I also wanted to check whether or not it was a palindrome. So I redefine arg as itself without spaces. And then I check as a true or false whether or not arg is equal to arg backwards. In fact, let's go ahead and print that. Let's just print arg backwards. And that works nicely, but if I feed it something else like newspaper, it simply reverses the word. It doesn't feed back a palindrome. Or Python. Python's not a palindrome, so reversing it won't work. So if arg is equal to reversed arg, return yes, else return no. And of course it's not a print statement, so I don't actually need the parentheses. That's a no. But if I feed it back D, go hang a salami, I'm a lasagna hog, I get back a yes. So my palindrome checker works nicely. Okay, that's a whole bunch of examples. I've also done a number of string methods. String methods that were covered in this were the following. Recap of string methods. We saw the following: dot upper, dot upper, dot lower, dot is upper, and dot is lower. We also saw dot replace, and then finally the reversal dot dot -1. Your challenge, rather than this last one, is to build your own string function that would receive any string and do something using these methods, and then share it in Slack. Build your own string function. Post it here in Slack where we can all see it. I'll provide the entire function in case it's useful to see how that was built out. Okay, so Regina, you have a nested print inside of a return.
I do, yeah.
And that's
I don't
not
need
causing
that.
an error message, but it's also redundant. You'll probably want to do either one or the other. Go ahead and time this page. If you're done, try running this in Jupyter Notebook and see what you get.